We can't easily model the way in which the climate is going to be changing during the next few years. And that gives one a definite sense of instability, a sense of not knowing what's coming. Is it going to be some extreme heating or cooling, or is it going to be some range of climate disasters? We just don't know.
Welcome to Facing Future. I'm Dale Walkinen. With me today are Paul Beckwith, climate scientist, and Professor Peter Wadhams, former head of ocean physics at Cambridge University. Today we're going to discuss all matters Arctic and climate. The Arctic is at the forefront of the climate crisis, and its glaciers are melting fast. Will there be an abrupt thaw that suddenly triggers a tipping point that threatens all life on Earth? And is there anything we can do in the climate crisis in general to mitigate these effects, or are we really facing a catastrophe in the near future? Thank you both for being here, wonderful members of our team. Paul, would you like to start?
Actually, I'd like to pass it over to Peter because I'm very curious to hear specifically about the Arctic permafrost thaw. We're getting less snow cover over the land, certainly in spring, which means that the Arctic is a much darker place. It's not reflecting as much sunlight. It's absorbing a lot more with less sea ice and less snow cover. And there's always a concern about methane coming up in large quantities to tip the climate over. So I think starting with Arctic permafrost and methane is a good place. So Peter.
Great. Peter.
Well, the main problem with Arctic methane is that there's so much of it, and it's just proliferating. When I started working on methane a long while ago, it was something that was a mild phenomenon that didn't seem to mean too much. Then a lot of intensive work was done on it by a group from Russia. And they were starting to look at methane in places where it wasn't expected to be. That is, in mountains, along the edges of ice sheets. Suddenly methane was everywhere. And now we actually can see methane properly. We can look at where it's coming from. It seems to be being emitted pretty much everywhere in the Arctic. And this methane is a very, very climatically active gas. And so it doesn't help the world if you have a large quantity of the gas being emitted. So we really have to worry about that. And then recently, of course, we had even more of an impact, which was the explosions occurring where large concentrations of methane were just being emitted in an explosive way, leaving big holes behind them, where people wondered where those holes came from. All of this is something which is unexpected and is a function of emissions which we don't know quite why they're so violently emitted. And one of the problems today is the larger quantity of methane that's being emitted, and we wonder where that's coming from and what it's doing.
Well, of course, there are many sources of methane, wetlands of all kinds, cow corpse, and our own industries and so forth. And we don't need any more of it. There's also nitrous oxide that I believe is emitted, which is another major problem from farmland and from permafrost. And of course, there's the Antarctic, which is the other question mark that we have. Paul, I wonder what you have to say about what's going on in Antarctica. I think there's some new news from that part of the world.
We've often thought that climate is changing everywhere on the planet rapidly, but Antarctic's pretty pretty solid place. Not much happening there. Very, very cold continent. 80% of the global population lives in the northern hemisphere. So it's just the Aussies and the Kiwis down in Australia and New Zealand and South Americans and so on. But we're seeing massive changes, abrupt changes in Antarctica in terms of sea ice loss specifically. So Antarctic sea ice was increasing about 1.5% per decade from the 70s onward. And then suddenly something seemed to break in the system around 2014, 2015. And the sea ice area and extent and concentration started dropping off a cliff, not just in the Antarctic summer, but also in the Antarctic winter. And since 2015, the loss of sea ice around Antarctica has even exceeded the loss of sea ice in the Arctic since the 70s. So it's happening very, very quickly. So I guess the main questions are why, because when you lose a lot of sea ice, you have to worry about how the ocean circulation patterns change. So the sea ice loss
Yeah.
and the warming in the Arctic, which many people, at least mainstream science now, says the Arctic's warming 4 times faster than the global average. What's happening in reality is the warming greatly depends on the latitude. The closer you go to the pole, the warmer, the faster the warming. It's called Arctic amplification. I prefer the term Arctic temperature amplification. But Antarctica has come up and surprised us. So the ocean currents, the AMOC has slowed down. That's being attributed to the great warming and fresh water entering the Arctic region from melt and reducing the strength of the AMOC, but the SMOC has slowed down significantly as well, which surprises a lot of people because many people sort of assume that with the AMOC slowing down, the SMOC would increase to compensate, but we're not seeing that happen right now. Also, I think people need to remember the sea ice in Antarctica is much, much further from the pole than it is in the Arctic. So when we lose that sea ice around Antarctica, the radiative effects, the albedo effects become that much more important because there's a lot more sunlight when you're away from the pole than it is right at the pole. So we're seeing massive changes to the overall climate system. I mean, climate change is definitely accelerating. The radiative forcing is much higher. We seem to be having fewer clouds, which means that more sunlight is hitting the Earth. Albedo of the Earth literally is becoming a darker place, right? It's darker. It absorbs more sunlight
Well,
and
some of the
reflects
clouds are
less.
beneficial to us, and some types of clouds, the higher clouds,
Yes, yes,
actually are detrimental. So it depends on the
yes. We're
type of
losing the
cloud.
beneficial ones, unfortunately.
Yeah.
Yeah.
And Peter, you've often talked about the blue ocean event in the Arctic. Do you see that coming upon us?
Um, well, not as quickly as I previously thought. A blue ocean event would be just when all the sea ice goes, bringing a large amount of open water from the melting of the ice, and the result would be pretty catastrophic. Except that it's not happening. It's not happening to that extent. And also, something that's sort of strange is the fact that the massive amounts of additional water coming into the ocean from melted sea ice is not causing sea level to rise as quickly as one expected. Given the production that's going on, I would have expected us to be experiencing a greater rate of sea level rise than we're actually seeing. So there's an interesting question is where's all that water coming from?
Well, of course, between the two poles is the AMOC. If
Well,
that collapses, it would warm the Arctic. And what would happen in Antarctica?
no, if think of the Gulf
It would
Stream.
cool the Arctic. Sorry,
Yes.
right?
Think of the Gulf Stream.
And
So it moves to the north, to the east, moves over to Europe, Northern Europe. It brings a lot of warmth to Europe, right, in the waters, and then it turns and goes into the Arctic. And when sea ice is being formed, it rejects about half of the salt and the other half is in brine pockets within the ice, which eventually then drains out, but it takes several years to do that, making the ice sort of purer and purer, just water and less brine pockets inside. But the water left over when the ice is forming on the fringes is very salty, and it's also cold, so it's heavy, so it sinks down to the ocean floor. And that happens at both poles. And that overturning circulation is crucial for the climate system because the water at the surface is oxygenated and it's got a lot of carbon in it, CO2, dissolved CO2 in it, carbonic acid, creating the ocean acidification. But when the water descends down to the deep, it takes the carbon down and it takes oxygen down, both of which are important. The carbon going down means that the oceans are a carbon sink. About half of human emissions, about half of anthropogenic emissions are absorbed in the ocean very quickly, and by this process taken down to the deep ocean floor. So with less vertical mixing in a more stratified ocean, you get less oxygen at the bottom, which is very detrimental to marine life that lives on the bottom. It's also very detrimental to us because the oceans are no longer such a powerful carbon sink. The ocean overturning is pretty vital for our present day existence on this planet. When it stops happening, then everything changes. It becomes much more difficult to grow food, I would imagine. It feeds into the atmospheric wind circulation patterns. You have to look at sort of the Earth as a heat engine. The equator's hot, the poles are cold. Heat wants to move from the equator to the poles. It does so in the ocean currents. It does it also in the atmospheric wind patterns. And then when the whole system is working as a finely oiled machine, if you like, the climate system, then, we have climate stability, but we're losing that climate stability and it becomes much more of a chaotic, nonlinear system.
So we don't really know what's going to happen, but we do know that in the past, the AMOC has collapsed. And we know that certain changes occurred on the Earth. And we do know that when carbon reached a certain level, certain changes are clear in the geology. So it isn't a blind game entirely, but there is so much, it's so complex that it's hard to say what will happen when. Peter, how do you feel about what's going on? And how's this affecting you you've been working on this for so many years?
Well, yes. Well, it's very worrying because the mechanisms that Paul has discussed are liable to give us extremes of weather that we don't expect and might be really extreme and be unexpected as well. We can't easily model the way in which the climate is going to be changing during the next few years. And that gives one a definite sense of instability, a sense of not knowing what's coming. Is it going to be some extreme heating or cooling, or is it going to be some range of climate disasters? We just don't know. And we haven't been in that position for a long time. We've been able to predict more or less how things are going to change, and now we can't. So I'm very worried about that.
Uncertainty is always very disturbing. I'm surprised that you are as uncertain as I am, being more informed, but I think we all are in a state of uncertainty, and now we have this insane administration in America, which is making us all extremely worried because they don't seem to have any understanding whatsoever, and the U.S. is not even attending the climate talks in November. So in America, it's a kind of a dark time, and I'm sure you're both grateful not to be here. Anyway, thank you both for this discussion. We covered a lot of topics, and I really appreciate your both participating in Facing Future.
Thank you, Dale.